Working with Mill Part 7 mating piece, my A-side programming has been completed. I also did a stock flip and face the piece to an overall length. I'll now be going over the spot drilling, and milling operations. The first thing I'm going to do is create a center point for my counterbore geometry. This will be used for chaining the milling operations. Next, I will go into turning, C-axis, and face drilling. From there, I will select my hole geometry. I will use a 3/8 spot drill and change my tool number to tool 8. Live tooling will work with even numbers on our lathes in the shop. Once the tool is selected, I will change the tip diameter and the number of flutes. My speeds and feeds do not reflect accurate machining parameters. The numbers I am choosing are safe numbers for student learning. From the linking parameters, I will enter a Z depth for a finished diameter. Then make sure that the tip compensation and coolant is off. I want to be able to see the cutting operation happening. Lastly, I'm going to turn on the rotary axis control to the C-axis so the spindle rotates for positioning. After saving my program, I will go into backplot and check to see that the cutting operation I want is operating correctly. You can see that the tool is moving where I just spoke about the C-axis and the spindle rotating. This will be able to be seen in your verification. Now I will copy the spot drill operation and then paste. This will be for my drilling ops, which I will need to change my tool and my tool number. My cutting parameters will also change to pec drill. My Z-depth will change, and then I will turn on tip comp. Everything else should stay the same from the previous operation. When the drilling operation is complete, I will now go into face contour in the C-axis tab. For chaining, I will select the center point I made earlier from the counterbore geometry and then the outside diameter of the counterbore geometry. Make sure that you are aware of the cutting direction for climb cutting. After, I will select a quarter-inch diameter end mill and change my tool number. Again, I will be using adjusted speeds and feeds for our learning environment. I will change my comp type to wear and turn on my depth to cut to a max of 50 thou. I will also turn on lead in and lead out with a length and arc of 10% and make sure to select use entry point. This will be the center point that we chained when we did our geometry earlier. For our linking parameters, I will select the counterbore face, but adjust the depth per the drawing. I will use a 0.260 depth for the counterbore. Last, I will confirm that the axis control is a C-axis and then generate the code. I will check my back plot to make sure that the tool is moving in the right direction. If the tool path is on the wrong side, I will go back, select the chaining geometry, and switch sides. These final views are of all the B-side cutting operations. You can see my facing, spot drilling, drilling, and circle milling. Moving over to the machine, I'll be removing the solid jaws and installing the soft jaws. After having my boring tool set up, I install my boring ring. From there, I will make a rotating clockwise or counterclockwise adjustment to the jaws for the correct clamping location. I have the clamping ring sitting on the face of the aluminum jaws, and I'm opening and closing the hydraulic chuck and adjusting the ring accordingly so I have the correct clamping location. Once the ring is in its correct clamping location, I'll use the VPS system on the lathe to cut my jaws to the desired diameter. I will also go in with the boring bar and cut a corner relief so the workpiece can sit flush against the face of the jaws. My final step is to install the live tooling. To do this, I will call up the tool number and then make sure that the turret is in its home location. From there, I will install the tools accordingly. I will use a probing system to set up my tool offsets. Remember to check for all tooling clearance when setting up all the tools.